Hello friends, today we will discuss the application of Huckel molecular orbital theory of conjugated system to 1,3-butadiene system. In part 1 we have already discussed about the secular determinants, energy levels and the calculation of total energy, pi bond energy and delocalization energy. As we know that the delocalization energy is also known as resonance energy and its value was 0.472 beta in case of 1,3-butadiene system, which clearly indicates about the more stability of the molecule as compared to the other one, for example, two ethylene molecules by an energy of 0.472 beta. So in this part, we will derive different secular equations and also the wave functions psi 1, psi 2, psi 3 and psi 4. We have already calculated the value of x. Four values we have already calculated, that is minus 1.618, minus 0.618, plus 0.618 and plus 1.618. So with the help of all these values, we will calculate the values of different A's, HMO's coefficients, and the corresponding wave function equations will also be determined. So first of all, for this, we form the secular equations with the help of these determinants. So A1, A2, A3 and A4 are the HMS coefficients. So for the first equation, A1 multiplied by x plus A1 into 1 plus A3 into 0 plus A4 into 0. So both of these will be equal to 0. So remaining would be A1x plus A2 is equal to 0. So A1x plus A2 is equal to 0. For the second one, A1 into 1 plus A1 A2 into x plus A3 into 1 plus A4 into 0. So the equation will be A1 plus A2x plus A3 is equal to 0. A4 into 0 would be equal to 0. So we have not written here. Similarly, A1 into 0 plus A2 into 1 plus A3 into x plus A4 into 1. So since A1 into 0 is equal to 0, so the remaining would be now A2 plus A3x plus A4 is equal to 0. Now the fourth one, so A1 into 0 plus A2 into 0 plus A3 into 1 plus A4 into x. So since A1 into 0 is equal to 0, into 0 is equal to 0. So the remaining would be A3 plus A4x is equal to 0. We know that the normalization conditions are A1 square plus A2 square plus A3 square plus A4 square is equal to 0. And the lowest HMO psi 1 that will be calculated, or the equation will be derived with the help of the main equation, that is psi is equal to A1P1 plus A2P2 plus A3P3 plus A4P4. So now we will substitute the value of x one by one and will determine the equation for the different wave functions. So first of all, we take x is equal to minus 1.618. Now substituting the value of x in equation number 21. So equation number 21 was a1x plus a2 is equal to 0. So we have substituted the value of x here. So minus 1.618 a1 plus a2 is equal to 0. Or in other words, a2 is equal to 1.618 a1. So equation number 26. Now from equation number 22, a1 plus a2x plus a3 is equal to 0, or we may write a3 is equal to minus a2x and minus a1. Since we know that a2 is equal to 1.618 a1, so we will substitute the value of a2 as well as x in this equation. So a3 is equal to minus 1.618 a1, minus sign is here. So a2 value is minus 1.618 a1 multiplied by x, that is equal to minus 1.618 minus a1. So it comes out to be 2.618 a1 minus a1, and if we subtract it, then it is a3 is equal to 1.618 a1. Now from the next equation, a3 plus a4x is equal to 0. So a3 plus a4, again substituting the value of x, minus 1.618 is equal to 0, or a4 minus multiply by minus 1.618 is equal to minus 3, or a4 is equal to minus a3 divided by minus 1.618. So that would be equal to, it will be cancelled out, so the remaining would be equal to a1. So a4 is equal to a1. Now with the help of these equation 26, 27 and 28, we may write in this way: a1 square plus a2 square plus a3 square plus a4 square is equal to 1. So substituting the value of a2, a3, a4 in terms of a1 in this equation, we get a1 square plus a2 is equal to 1.618 a1, so its whole square, plus a3 is also equal to 1.618 a1 square, a1, so its square, plus a4 is equal to a1, so instead of writing, we will write here a1 square, that is equal to 1. So if we calculate it, then the value of a1, it comes out to be 0.372. So with the help of the value of a1, we may calculate the value of a2, that is equal to 0.602, and a3 is also 1.618 a1, so substituting the value of a1 here, so we may get the value of a3, and we know that a4 is equal to a1, so that would be equal to 0.372. So substituting the value of a1, a2, a3 and a4 in the main equation, so psi1 is equal to a1p1 plus a2p2 plus a3p3 plus a4p4. So a1 is equal to 0.372, a2 is equal to 0.602, a3 is equal to 0.602, and a4 is equal to 0.372. So first equation for the wave function we have determined. Now from the second value, that is x is equal to minus 0.618, we may again calculate, and a value for the equation for side 2 may be determined. So from this equation, that a1x plus a2 is equal to 0, so substituting the value of x here, minus 0.618 multiply by a1 plus a2 is equal to 0, so a2 will be equal to 0.618 a1. Now a3 is equal to, we know that minus a2x minus a1 is there, so substituting the again the value of x and a2, we get the value for it, that is minus sign is here, so 0.618 a1 multiply by minus x is equal to minus 0.618 minus a1 is equal to 0. So a3 will be equal to, if we calculate it, it comes out to be this one minus a1. So a3 would be equal to minus 0.618 into a1. So now a3 plus a4x is equal to 0. So a3 plus minus 0.618, again the value of x multiplied by a4 is equal to 0, or a3 is equal to minus 0.618 a1. So we have substituted the value here, plus minus minus, so minus 0.618 a4 is equal to 0, or minus a4 is equal to 0.618 divided by 0.618 multiplied by a1, that is equal to a1. So minus a4 is equal to a1, or a4 is equal to minus a1. Now again the normalization conditions. So a1 square plus a2 square plus a3 square plus a4 square is equal to 1. So a1 square plus a2 is 0.618 a1, a3 is minus 0.618 a1, and a4 is equal to minus a4 is whole square is since a1 is equal to minus a4, so if we will do it its a square, then it would be equal to a1 square, that would be equal to 1. So if we calculate the value, then a1 is equal to 0.602, a2 is equal to 0.618 multiplied by 0.602, so it would be equal to 0.372. Then a3 is equal to minus 0.618 multiplied by 0.602. So that is equal to minus 0.372. And since A4 is equal to minus A1, so it would be equal to minus 0.602. So in this way, we may write the equation for psi 2 by substituting the value of A1, A2, A3 and A4, 0.602 P1 plus 0.372 P2 minus 0.372 P3 minus 0.602 P4. Now we may take the value for x is equal to plus 0.618. Then again in this way we may derive and may get the equation for psi 3, that will be equal to 0.602 P1 minus 0.372 P2 minus 0.372 P3 plus 0.602 P4. Similarly, x is equal to, if you will substitute the value plus 1.618, then we may determine the value for psi 4, or the equation for psi 4, that is equal to 0.372 P1 minus 0.602 P2 plus 0.602 P3 minus 0.372 P4. So in this way we have determined the values for the wave functions for the 1,3 butadiene, psi 1, psi 2, psi 3 and psi 4. So the graphical plots of these HMOs along C1, C2, C3, C4 axis, and the section of three-dimensional shapes are shown in the figure. First of all, we take the graphical plot of these HMOs along C1, C2, C3 and C4 axis. Here you can see that Psi1 was 0.372 plus 0.602 plus 0.602 and plus 0.372 P4. So here the value was 0.372 P1, and here the value was 0.372 P4, or here it was 0.602 P2 and here 0.602 P3. So in this way psi 1 may be represented. Similarly, psi 2, we know that there is psi 1 has no node, but psi 2 has one node. If you see the equation of psi 2, then it is 0.602 P1 plus 0.372 P2 minus 0.372 P3 minus 0.602 P4. So here you can see value 0.602, 0.372 P2, then 0. It has one node because minus sign is there, so minus 0.372, so 0.372 and 0.602 P4. Then psi 3, it has two nodes, we can see here. So the equation was 0.602 P1, then it was minus 0.372 P2, then minus 0.372 P3, then plus 0.602 P4. Then similarly, psi 4, it has three nodes. You can see here first, second and third. So equation was 0.372 P1, then minus 0.602 P2, then plus 0.602 P2, then minus 0.372 P4. So in this way we can represent its graphical sketches. Then these are the sections of the HMOs along a vertical plane. You can see here very well, as psi 1 has no node, so all the sign with plus here, then here negative. Then psi 2, it has one node. Then psi 3, it has two nodes. Then psi 4, it has three nodes. So in this way we have represented the sections of the HMOs along a vertical plane. So with the help of these HMO coefficients, one can calculate easily the bond order, the charge density. We can also calculate free valence of the system. So we have already calculated the bond order as you have seen in the other lecture. So thanks.